we have looked at rational exponents. If your power is a fraction, you can turn that into a radical, and vice versa. If you have a radical, you can always rewrite that power as a fraction, so we've seen that before. Exponential notation is anything where the exponent is your variable. Okay, so we're used to seeing x to some power. But if I flip that, if I have like 2 to the x or 1/2 to the x, those are exponential functions. So it is important we might have fraction powers. Remember that property there that we saw in the last chapter. But the big thing that we're talking about today is that exponential notation. So an exponential function is f of x equals a to the x power. A is just a number other than 1, and it's called the base. And then your variable is your exponent. So first, let's just make sure we kind of understand what this looks like and we can evaluate some of these. So if I said our function is 4 to the x, if I ask you to find f of -2, so that just means in your function you're replacing your exponent with -2. What does a negative power mean? And it becomes a +2, and what is 4 squared? Right. If I ask for f of 5, that just means 4 to the 5th power. Use a calculator if you need to. What does that turn out to be? Can I flip this? Can I make it 3/2 so we can do it by hand instead of just plugging in the calculator? Pretend this is f of 3/2. So if you have 4 to the 3/2 power, what does that mean?
Square root of 4 times to the 5th.
Okay, what is the square root of 4?
2.
And 2 to the 3rd? 8. And your exponents don't always have to be nice. We're used to seeing fractions or integers, but you could certainly have decimals. We just put those in the calculator. So if I said something weird like 2.15, it's not nice, but it does.
How many would you like us to use around?
4 decimals is good for me.
So the 4th one would be rounded.
Yes, so you look after the 3 is a 1, so we keep it the same. Round up if the next digit is 5 or more. Are those okay? So if we want to graph exponentials, we can go back and use same strategies as any other time. If we don't know what a graph looks like, we start by making a t-chart. So we're going to graph a couple different exponentials. 2 to the x and 1/2 to the x. And then we'll answer some questions about each. All right, so if I said 2 to the x power, if I want to figure out what that looks like, what do we do? So if I start with 0, what's anything to the 0 power? 1. So 0, 1 is a point. If I put in 1, what's 2 to the 1st? 2. If I put in a 2, what's 2 squared? All right, and that's just going to keep getting bigger. Let's go with some negatives. If I put in -1, what's 2 to the -1 mean? What's a negative power do? Mhm. So -1/2. If I put in -2, that's 1/2 squared, so 1/4. Are you ever going to do 2 to a some power and get 0 out? No. So this graph, remember these from Algebra 2? It's exponentials, they're curved. It has a horizontal asymptote here. It's going to keep getting closer to 0, but it doesn't actually hit it. What's the domain of this function? What x's does it hit?
Negative positive.
Keeps going forever. Bless you, they always will. Range. I only get out positive numbers, so it's 0 to infinity. The 0 gets a parenthesis. We don't ever equal 0. We just get things bigger than that. Is this graph increasing, decreasing, or constant? Increasing the entire time. What kind of asymptote does it have?
It has a horizontal at 0.
Mm-hmm.
So how do you know if a graph goes to infinity or if it's just got an asymptote at like 3?
Oh,
Like
the
if it had a
verticals.
asymptote at 3.
You could keep plugging in points if you did 3 to the third is 8. You can plug in 4. You can keep putting in these x's. So you can, as long as you can continue plugging x into your equation, it keeps going. All right. Let's do 1/2 to the x. So if I make my t-chart for that, when you graphed exponentials with Mrs. Keller, you start out doing a lot of points, but eventually you realized you really only need a few points to get the idea of what your graph looks like. When you're graphing these exponentials, you at the very least have to put in -1, 0, and 1 for your x. Those would be the points that we always plug in. And then if you're not sure about your graph, you can certainly do more, but that's kind of our basics. What is 1/2 to the -1 power? 2. It just flips it. So we get -1, 2. 1/2 to the 0. Anything to the 0 power is 1. If I put in 1, 1/2 to the first is 1/2. Is that enough to know what my graph looks like? Yeah. You could always do more if you wanted. If you put in -2, you're going to get out 4. If you put in +2, you get 1/4. So it looks a lot like the previous one, except it's backwards. So what's my domain? The range, what y's do we hit? Everything bigger than 0. 0 gets parentheses because we don't ever hit it. Is this one increasing or decreasing? And we still have that horizontal asymptote at 0. So in general, these exponentials are going to always look very similar. You're always going to have a horizontal asymptote. Your domain is always everything. The first one is increasing because my base, the number being raised to power 2, is bigger than 1. If your base is bigger than 1, it's increasing. This one, my base was smaller than 1 because of the 1/2, so it was decreasing. So if your base is bigger than 1, it'll go up. If it's smaller than 1, it'll go down. Otherwise, they're basically the same. Any questions there? I want you guys to take a couple minutes and see if you can sketch the graph for each of these. I want at least 3 exact points on each graph. And I don't care if you write the t-chart out to the side or just clearly make sure the points are on your graph where I can tell what they are. always at a minimum 3 exact points. All you really have to plug into the equation is -1, 0, and 1. For the -1 is 1/4, for the 0 is 1, for the first is 4. Then I do expect those points to actually be plotted on your graph, so don't just draw me a shape with no points on it. So we have -1, 1/4, 0, 1, 1/4. It's increasing because the base is bigger than 1. When you do your 1/3, what's 1/3 to the -1? And 1/3 to the 0, and 1/3 to the first. So we have -1, 3, 0, 1, 1/3. And looks like everybody got those two graphs. So no problems with our basic functions here. What I want to do next is just talk about some transformations of these. So we'll do a few examples until you guys feel confident, and then I'm done, okay? So just looking at all the transformation rules that we've used in the past. All right, if I'm asking you to do it with transformations, I would ask that you graph the parent function and the final function. What is my parent function? The parent function is your regular exponential, just a positive number to the x power. So in this case, it would just be 3 to the x. If you wanted to graph that, you would have to do points. What's 3 to the -1? -1, 1/3. If I put in 1, what's 3 to the first? Or sorry, 3 to the first is 3, and if I put in a 0, 3 to the 0 is 1. So you get your original points. How do we graph a parent function? All right, now we have to think about what the transformation would do. All right, a negative out in front does what to our graph?
Do you have a spare microscope?
It's like making all of our y's negative. So if I reflect this over the x, it goes here. So my actual graph looks like this. Can you tell me what the domain of that function is? What is the range of that function?
Attention please, this is a test of our intercom system. This is only a test. Thank you.
I know, every day. What would our range be? Just for the final one, so the final one is just negative infinity to 0, because it stops when you get to that horizontal asymptote.
How did you get 0 again?
When I'm looking at this graph, it's starting down here, coming from negative infinity, and it stops when I get to our horizontal asymptote of 0.
Yeah, I see what you're saying.
Other questions? What if I did, I don't want to do that. I'm going to do this one. 3 to the x with a -2. So my parent function is the same one, right? 3 to the x. So we had -1, 1/3, 0, 1, and 1/3. -2 due to our graph?
Move it to the right, two, or is it down two?
If it's attached to the x, that's left and right. If it's on the end, that's up and down. So this one will be down 2. Okay, so if I move each of these points down 2, what else do I need to move other than just those 3 points? We had a horizontal asymptote at 0. When you move up or down, that horizontal asymptote gets moved as well. So my horizontal would come down. If I move left or right, does it change the asymptote? No. So my domain is still negative infinity, positive infinity. What does the range turn out to be this time?
Why did it last time go from negative infinity to positive infinity?
The range went from negative.
Yeah.
You guys think you can try one? Here is yours. I just want you to graph the parent function with at least 3 points and your final function with 3 points. So parent function is your 2 to the x power. So -1 gives us 1/2, 0, 1, and 1, 2. That's your dashed line. You could certainly do more points, but that's your minimum. What will the +1 do? So take each of those points to the left. Any questions there? So same transformations we've done in the past. Let's do, I'm gonna do one more. Okay. This one has a couple different transformations with it. So our parent function is still 2 to the x. And so you start with the 3 points on 2 to the x. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. So we can plot those. -1, 1/2. 0, 1, 1, 2. Parent function we always do dashed. What will the -3 do to my graph? And what does a negative on the x do? Reflect over. If it's out in front, it's making the whole thing negative, so it flips it over the x. If it's attached to the x, it's changing the sign on your x's only, so it reflects over the y. So first of all, since we're moving down, the horizontal asymptote gets moved down. So if I go to -3, I can draw in my horizontal asymptote. So I have to take each point. -1, 1/2. If I reflect that over the y, it goes to +1, 1/2. And then move it down 3. So it becomes 1, -2.5. If I take 0, 1 and reflect it over the y, it doesn't go anywhere. Down 3. If I take 1, 2 and reflect it over the y, it goes to -1, 2. And then down 3. So the final graph looks like that. So we could have multiple transformations on one. Any questions on that?